Chapter 2, Section 5 deals with interest. The content objective is that students will solve problems involving simple interest, and if you look at the suggested pacing, we should be able to knock this out in one day in the classroom. How can you earn money by saving money? Well, the word is interest. Interest is defined as the amount of money earned for the use of money. So basically what's happening is you're investing your money someplace else. Whoops, I missed the I there. You're investing your money and somebody else is spending your money and paying you to use your money. That's the way banks work. When you deposit money into a bank, the bank turns around and gives your money to somebody else in the form of a loan. And that they charge those people interest on that, and then they give you a teeny tiny little piece of that interest back yourself. A bank offers 3.5% annual interest if you deposit $500 for 1 year. And I gotta say, 3.5%, that is huge coming from a bank. And other things like a stock market, it's horrible. But when it comes from a bank, 3.5%, I'll be shocked if you actually see that. Bank B says they're going to pay you 1.25 annual interest if you deposit $600 for 1 year. Which bank do you think will pay more money to deposit your money over the course of 1 year? I'm thinking, 3.5% is a whole lot more than 1.25%, so Bank A is probably going to be the way to go. And with that, we're going to get started on our lesson. How is the amount of interest earned on a deposit related to the length of time and the interest rate? All those three things combined come together, and you're going to use some pretty cool e-tools to explore this question. So let's see what it's going to look like. Oh, I just made it speak. Creepy. Sam deposited $200 into a 5-year account that earns 3% annual simple interest rate. The table shows the amount of interest earned over 5 years, and it wants us to take and graph those points. So let's take and pick a pretty color. Oh, no color choices today. All we can choose is black, so we're just going to use black, and we're going to plot those points. At 1 year, he had $6 interest. So let me get we're going to need 5 points. So at 1 year, he had $6 interest right there. At 2 years, he had $12 interest. So the next dot is going to be at 2 and 12. 3 years, I'm betting it's going to be $18 interest, is it? Yep. 4 years is going to be $24 interest, and that means 5 years, I bet it's going to be $30 interest. So there's your table of stuff, and there is a graph of what the interest looks like. As you can see, this is a linear progression, and we also know it's going to be a proportion, because we've learned before that a proportion creates a straight line and goes to the origin, and that's exactly what you see here. So let's talk about what we're actually seeing. What does 0.00 represent? Remember, 0.00 is called the origin, and the origin is going to be your starting point. That means at 0 time and 0 money put in the bank, that is how much interest he would have earned. At 0.16, well, that represents that in 1 year's time he earned $6 interest, which really isn't that much money to earn over the course of an entire year. Now we're stepping up our game a little bit as the problem asks you what's the constant of proportionality. And if you remember from last chapter, we had a formula that said y divided by x, and that's not a very pretty x there, is it? Divided by x is equal to our k value, our constant of proportionality. And we can pick any point. And the point I'm going to pick is the first one because that's the one that's easiest to work with. 0.16, my y value is 6. My x value is 1, and that means that the constant of proportionality is going to equal 6. And it doesn't matter which one of those ordered pairs you work with, you're going to get the same constant of proportionality there. So we're going to plug in a 6 for our constant of proportionality, and that checks. Next, it says proportional relationships can be written as equations in the form y equals kx, where k is the constant of proportionality. Use a constant proportionality to write an equation that represents the relationship between interest y and time x. Well, what did we say? We got the formula right there. Y is equal to kx. Well, that didn't highlight very well. What does k? Well, right here we found that our k value is going to be 6. So we're going to put 6 in. Y is equal to 6 times x will be the formula, so that you can say, well, what about 10 years from now? Put 10 in for x. 10 times 6, $60. Easy math. So how is a constant proportionality, which is 6, related to the values in the problem? Well, the initial deposit was $200, the interest rate was 3%, and the time was 5 years. That is where it's all going to come down to. We're going to have to be using a formula for calculating simple interest. Now I'm going to go ahead and throw you a bone here that you're going to need for the next part of the problem. It's the interest formula. And the simple interest formula says interest is equal to principal times the rate times the time. And on the next problem, it wants you to be able to take and look at this chart and look at this information provided here and fill out this equation. Well, first off, we know that on this side you have interest, and from there we're going to have the principal. The principal is going to be your initial deposit. Your initial deposit is the principal amount that goes in, so $200 goes there. And then the rate is going to be your interest rate that you see right there, 3%. And of course 3% written as a decimal is 0.3, and then times the time is going to be the last part. And your formula checks interest times principal times rate times time. Now the textbook wants us to test that formula on the other data in the table and see if it works. So we're not going to make them you test them all, but I do want to test a couple of them where I've gone over to the formula I have here, interest equal principal times rate times time, where now I can say, well, interest is equal to the principal we said was $300, nope, $200. So $200 times the rate was 0.03. And what time do you want to use here? 1, 2, 3, 4, or 5 years? I'm going to start simple. Let's try 1 year. So times 1 year, and when we grab our calculator here, we can take and look at it, and that's going to be 200 times 0.03 times 1 is going to equal to 6. So for that one, interest equal to 6, which, hey, looky there, it worked. Let's try another one. Let's take and do it with the 4 years. So now I have interest is equal to, my principal is $200, my rate is going to be 0.03, and now my time is going to be 4 years. Grab our handy dandy calculator again, 200 times 0.03 times 4 years, that gives me $24. Interest is equal to $24, which is the same thing we got right there. The formula is going to work, but did you notice anything particular about the unit of time? The unit of time is always based on years. That's what the simple interest formula is designed to work with, is years of time. Now that leads us to an inquiry question of how is the amount of interest earned on a deposited related to the length of time and the interest rate? Well, the longer the money is in the bank, the more interest you're going to get. The higher the interest rate, the more money you're going to get. So let's start getting down into the meat of the lesson. If you borrow money or deposit, the principal is the amount of money borrowed or deposited. That looks like something on a vocab quiz. Interest is going to be the amount paid on the principal, another term for your vocab quiz, and simple interest is calculated using specific time periods, another term for your vocab quiz. Percents are used to calculate interest. You can earn interest by letting a bank use the money you deposit in the bank. You will always pay interest if you borrow money from the bank or carry a balance on your credit card. Now we're going to watch this animation about interest, principal, rate, and time.
The formula for finding simple interest is I equals PRT.
I showed you that.
Simple interest I is the product of the principal P, the annual interest rate R, and the time T, expressed in years. Rosie puts $430 into a savings account that pays 2% simple interest. How much interest will she earn in 5 years? Use the simple interest formula to find the right amount of interest Rosie will earn. Replace P with 430, R with 2 hundredths, and T with 5. Find the product. I equals 43, so Rosie will earn $43 in interest in 5 years.
Okay, well that did a good job of explaining the simple interest formula to us. Let's dig in and learn how to use it a little bit better on our own. We're going to start off looking at these flip cards. In words, simple interest I is the product of the principal P, the interest rate R, and the length of time T expressed in years. Using formulas, you have I equals PRT, otherwise known as interest is equal to principal times rate times time. Magdalena put $580 into a savings account. The account pays 2.5% simple interest each year. She neither adds nor withdraws money from the account. How much interest will she earn after 2 years? The period of time is annual, yearly, the period of time is annual or yearly, so T is equal to 2 for 2 years. Your rate is 2.5%, and your which is 0.025 is a decimal, and the principal, of course, is the 580. So when we work through that, let's find out what we're going to get here. So our next line, I'm going to write the I for interest again is equal to my principal, $580. My rate is going to be 0.025. That came from the 2.5% you see right here. And the time was in 2 years. Grab your handy dandy pocket Satan. 580 times 0.025 times the 2 years time, and we're going to find that she's going to earn of $29 interest in that 2-year time period. Go back to our problem, scroll down, she's going to earn $29 in 2 years, and the answer checks. Excellent. We're going to start off looking at these flip cards. In words, simple interest I is the product of the principal P, the interest rate R, and the length of time T expressed in years. Using formulas, you have I equals PRT, otherwise known as interest is equal to principal times rate times time. Magdalena put $580 into a savings account. The account pays 2.5% simple interest each year. She neither adds nor withdraws money from the account. How much interest will she earn after 2 years? The period of time is annual, yearly, the period of time is annual or yearly, so T is equal to 2 for 2 years. Your rate is 2.5%, and your which is 0.025 is a decimal, and the principal, of course, is the 580. So when we work through that, let's find out what we're going to get here. So our next line, I'm going to write the I for interest again is equal to my principal, $580. My rate is going to be 0.025. That came from the 2.5% you see right here. And the time was in 2 years. Grab your handy dandy pocket Satan. 580 times 0.025 times the 2 years time, and we're going to find that she's going to earn of $29 interest in that 2-year time period. Go back to our problem, scroll down, she's going to earn $29 in 2 years, and the answer checks. Excellent.